Greetings to ladies and gentlemen, attendees of CITES 2020. Let me introduce myself. My name is Aidil Arief, and I'm one of the author of this paper. And in this opportunity, let me present about preparation smallest PVA Binahong Leaf nanofiber for wound tracing applications by varying electrospinning variable using Taguchi method. In this presentation, I have four contents for you all. The first one is introduction, next is electrospinning, and then research method, and the last one is results. Let me get into the introduction. This is the picture of a wound. Wound is a condition where you have a tissue skin exposed to air, and you have, if not treated immediately, it will cause infection. And the next in here is the picture of Binahong leaf. Binahong leaf is a medical herb that good for wound healing. And then I have a picture of electrospinning. Electrospinning is a method to create fiber. And in this research, I would like to produce Binahong fibers to treat a wound. The next is Binahong. This is a picture of Binahong. Some people in Indonesia call Binahong is as gondola, and Binahong is good for wound treatment, wound healing, or wound surgeries. And Binahong have four parts, namely its leaves, stem, roots, and flower. All of the part of Binahong has its own chemical contents. As you can see, the leaf have the most chemical contents of the Binahong plant, and each of the chemical content has its own benefits, such as saponin is good for cleanser and antiseptic. Flavonoid is good for destroy the microbe that causes infection. Triterpenoid is for regenerate infected cell, and alkaloid act as bacterial. Next, we get into electrospinning. As I said earlier, the electrospinning is a method to create long fibers by using a high potential electric field. This is the picture of a schematic of electrospinning. The schematic of electrospinning have three parts, namely collector, emitter, and power supply, where the collector and emitter is connected to the power supply. In electrospinning, we have Taylor cone at the end of the siring. This is the picture of Taylor cone. As you can see in this picture, the polymer solution in the siring is positively charged as it connects to power supply. Next, we get into electrospinning parameter. The parameter of the electrospinning have many parameters that will affect the fiber morphology. In example, when we have a low viscosity, it effect has a bit formation, and we have high viscosity, it creates larger fibers on fiber. And all of it can you see in the presented slide. And next, we have got into research method. In this research method, I have three parts. The first one is Binahong polymer preparation, electrospinning setup, and observation. Binahong polymer preparation. To prepare a Binahong polymer, we use some steps. The first step is soak ground Binahong in 95% ethanol for 2 days. Next, stir Binahong extract and slowly add polyvinyl alcohol. And next is viscosity of polymer calculated by utilize Stokes law. This is the table where the viscosity of each sample is calculated. Next, we have electrospinning setup. The electrospinning machine we set up by using the preparation, the siring pump mechanism, collector mechanism, and the high voltage power supply that is attached to the siring and collector. This is a picture of electrospinning machine that is set up. And next, observation. The observation was carried out by using Olympus stereo optical microscope. The results, by using Taguchi method OA or design of experiments, Taguchi method was utilized to make experiment more efficient, simple, and robust. The orthogonal array used was L9 with 3 factor and 3 level. This is the table of Taguchi method orthogonal array L9 and its corresponding average fiber diameter. And the next is this is the picture of main effect plot for means. In this picture, you can see that at a distance 8 centimeter, voltage 20 kilovolt and percentage weight total PVA 8%, we create the most smallest fiber. Contrary to that, we have main effect plot for SN ratio. In SN ratio, we use the signal to noise ratio smaller is better setting because the target of this research is to produce the smallest fiber as possible. And if you have at the distance 16 centimeter, voltage 15 kilovolt, and percentage with total PVA 12%, we have the most lowest variability of the research. The next is ANOVA. ANOVA, or analysis of variance, used to analyze the parameter that affect the experiment. We have two hypotheses in ANOVA. The first one is H0 is a residual data that normally distributed, which mean that variable not affect the fiber diameter, and H1 is residual data that not normally distributed. Or another word is variable affect the fiber diameter. We have a criterion of this is H1 accept and H0 decline if value of P smaller than alpha, when alpha is 0.05. This is the ANOVA result. As you can see, distance and percentage with total PVA is P value of distance and with total PVA is more than 0.05. It means that distance and percentage total PVA is affect the diameter fiber when the voltage, the P value of voltage is bigger than alpha, and then the voltage is not affect the fiber diameter. With the distance, contribution is around 33%, and percentage with total PVA is around 74%. The confirmatory test. The confirmatory test was conducted to find out whether this experiment was confident enough. In earlier plot for means, and we see that at the distance 8 centimeter, voltage 20 kilovolt and percentage with total PVA 8%, it will produce the smallest diameter fiber that, and prediction value from Taguchi is around 0.45 micron. And this is the picture of confirmatory test result. We got the confirmatory result around 0.44 micrometer, and we have confidence limit around 5%. And this confirmatory result is in confidence limit of predicted value, or in other words, the experiment is confident. The conclusion. First is smallest fiber diameter was reached at 0.44 micrometer, where the variation of distance, voltage, and viscosity of PVA is 8 centimeter, 20 kilovolt, and 8% respectively. And then next is the closer the distance spinner to collector and less viscous polymer result in smaller fiber diameter. And next is tape and collector distance contribute to fiber diameter by around 23% and viscosity around 74%. And the last is smaller fiber diameter. Smaller fiber establish faster absorption on body, therefore faster wound healing. Further research needed to confirm characteristic of Binahong nanofiber, wound raising, and other material possibilities. And I think that's all for me. If you have any question, feel free to email me anytime. And to close this, I say thank you for attention. Thank you all.